Hello friends, my name is Lalit Soni and you are watching In News by Drishti IAS. In today's episode, we'll be discussing about a rocket launch which has been done by private players in India. So that is a significant step for India and our space sector if we talk about. So let's start. Agniban rocket launch, a turning point for India. We will see why it is a turning point, and when we are talking about this particular rocket, that is Agniban rocket, it has been launched by Agnikul Cosmos. Okay, so it becomes important for us to see like how private sector is becoming part of our space journey. So let's start our discussion. In today's discussion, we'll start with the news and then we'll talk about the key features of Agniban. We'll also see what rocket has been used in that and what are the key features of that rocket. The name of the rocket is Agnilet. So these names like Agniban, Agnilet, Agnikul, these becomes important for you. You should know that which is the company, which is the rocket and which is the engine. Okay. Now we will talk about the significance. We will see that what is the significance of private sector in our space industry and why government is promoting it. Now we will end the session with the practice question. Okay, so when we are talking about this particular topic, that is you can say a rocket launch which has been done in the space sector, so that is basically important from the GS3 papers point of view in the space technology. Okay, so let's start our discussion over here. So the news is that a private space company, that is Agnikul Cosmos, carried out the first successful launch of its indigenous built rocket last week, opening up a new chapter in India's space sector. Okay, so they are saying that this is no doubt a new chapter, but when we are talking about the private players and their rocket launches, this is not the first time. Okay, earlier there was this another company, that is Skyroot. They have also gone for such rocket launch in November 2022. Okay, so definitely this is the not the first time we have gone for the private rocket launch. But the thing is, there are certain aspects to it from which we can say that there are very different aspects are there which are done for the first time. Okay, we will see in the further slides. With private players also coming in space has become a sunrise sector that government is promoting heavily. Now government is promoting the participation of the private sector in the space so that ISRO can focus more on the R&D. All the commercial services can be provided by the private sector, and private sector is mostly, you can say that it is efficient and there are competencies in the private sector. So when we are talking about the space sector as well as the defense sector, we are promoting more and more private sector in the space as well as defense. Okay, so moving further, here you can see what are the key features of the Agniban. Okay, so looking at the key features, as I told you, it is indigenously developed. Okay, so it is entirely in-house developed by the you can say Agnikul Cosmos, and it is a Indian startup, you can say. So that is one thing. Second thing is, here we have used a rocket, or in rocket there is this engine. That engine's name is Agnilet. Okay, so name of the engine is Agnilet, and Agnilet is built in-house. Second thing is, it is used or you can say the technology used in the building of this particular rocket is 3D printing. So this is not the first time that they have gone for the, you can say, use of 3D printing in the space sector, but this is for the first time they have printed an entire, you can say, engine, rocket launching engine by this particular technology. So that is also one of the first which we have done. Okay, so that we have used 3D printing in the entire rocket engine making. Okay, when we are talking about this Agnilet, there are another features, that is it is a semi-cryogenic engine. Semi-cryogenic means that this particular engine will have a particular stage or wherein the fuel will be used, that is oxygen. Okay, you can say cooled oxygen gas will be used over here. So that is there. So when we are talking about the cryogenic engines, mostly they will go for the, you can say, low temperature gases as a fuel. Okay, so that is what cryogenic is. Okay, the word cryo means that there should be a low temperature. Okay, so it is a semi-cryogenic engine which is entirely 3D printed. As I told you, it is 3D printed. The engine does not have any components or moving parts at all. When we are talking about this technology, that is 3D printing, you know that it is a layer by layer printing. Okay, so let's say if this is the shape of the rocket which has been prompted to the 3D printer, so what will they do is that they will use the material and it will go by the layer by layer printing of it, and ultimately it will be a single component which has been printed by the 3D printer. Okay, now traditionally if we speak that rocket launchers or the engines are built by different components, first these different components are built and then they are assembled together. But when we are talking about this AgniLet, there is no different component. It is a single component which has been printed by the 3D technology, 3D printing technology. Okay. So when we are talking about the different components, and see, making of the different components, there are various stages. Okay. Then assembling of these various components, then it will also be done in the stages. When we are talking about these stages, the more the stages, more there will be a chance of error. But when we are talking about this particular, you can say, rocket which has been made by 3D printing, there is a single stage in which this particular thing was built. So we can say that chance of error is minimal over here. Okay. So we can say here is there are not many components, or does not have any components or moving parts at all. There is no joints, no welding, no fusing. It is a smooth single piece of hardware. So there are these stages has been avoided so that the chance of error will be less. Now 3D printing can increase the efficiency because obviously chances of error are less, bringing down the cost and reduce the probability of something going wrong by eliminating the potential source of error. As I told you, we have eliminated the stages, so that is why we have eliminated the potential source of error as well. Okay. So these are certain features. More than that, we will talk about these features like Agnibaan's launch has been done by the privately owned pad. When we are talking about these launching pad, ISRO has 2 pads in Sriharikota. Most of the private sector, they actually what they do is that they go for the help of ISRO, and they launch their satellites from this particular you can say launching pads which are there in Sriharikota. Okay. So there are 2 ports in Sriharikota. When we are talking about this Agnikul, or when we are talking about this Agnibaan, it has been using its own launching pad which has been made by or made with the help of ISRO only in Sriharikota. Okay. So we can say that ISRO has 2 you can say launching pads in Sriharikota, and 1 launching pad is made by the Agnikul over there for their own launch. Okay. So when we are talking about this launch, there is a capacity of 35 to 45 launches of Agnibaan rocket annually. Okay. With that capacity, launching pad has been built. Okay. Now when we are talking about these launching pads, since the you can say frequency of satellites is increasing, so ISRO is also going for a second spaceport center. You can say that ISRO is developing a second spaceport in Tamil Nadu for SSLV launch to accommodate the increase in the launch activities. Okay. Now it is your job to tell me that where this second spaceport is located, or they are planning to locate it. Okay. It is somewhere in Tamil Nadu. Okay. And you will answer me in the comment box that where it is located. Okay. Now when we are talking about these launching pads, as I told you, it is having a capacity of 35 to 40. When we talk about this Agnibaan launch, it is having a capacity of 30 kg to 300 kgs. There are different stages, there are different phases in which there are different variants of this rocket launcher which launches you can say satellites from 30 kg to 300 kgs. Okay. And similar is the case with the Skyroot's Vikram. Skyroot is another company which has launched its Vikram rocket in 2022, and they also go for the you can say small satellite launch vehicles, and they are also having a capacity similar to 30 to 300 kg. Okay. So that is about it. Moving further, what is the significance? Okay. So government support and diplomatic outreach. As I told you, now we are going for more and more private sector's participation. Okay. Because obviously government has a resource crunch, we have a limitation. Government cannot be part of every venture when we are talking about the space. So Indian government is actively promoting private participation in the space sector. This includes fostering collaborations and inviting global investment, positioning India as a growing hub for the space technology. As private companies continue to expand their operations and technological achievements, India is poised to become a significant player in the global space market. India is doing really good in the space sector. When we are talking about our, you can say Aditya L1, Chandrayaan 3, when we are talking about the other space mission as well, India is a reliable partner. India is a reliable, you can say contender when we are talking about the space market. So obviously we have more potential, and now to exploit that particular potential, we have actually thought of utilizing the private sector in this particular industry. Okay. Now here when we are talking about the Skyroot's aerospace pioneering effect, when we are talking about the participation of private players, this is the first company which has gone for the rocket launch, or that is Vikram. That name was, you can say, given after Vikram Sarabhai, Dr. Vikram Sarabhai. Okay, so here you can say prior to Agnikul's launch, Skyroot Aerospace successfully launched Vikram rocket in November 2022, making first private sector launch in India. When we are talking about ISRO's SSLV, as I told you, these private sectors are mostly going for the small satellite launch vehicles. Okay, So ISRO is also developing their own small satellite launch vehicle so that they can go for the technology transfer later. But the thing is, there is a difference. The private sectors is going for the 30 to 300 kgs. ISRO is going for a 500 kg. Okay, 500 kg capacity. We have already made it, and it is also under the, you can say, R&D. More and more R&D is done on that. We have gone for 2 of such launches till now. One of them was successful. Okay, so there is a requirement of more, you can say, R&D in this particular sector. Okay, so with that, we'll move to the practice question, because we have talked about this and that much is sufficient for your exam point of view. Now, which district in Tamil Nadu is the second spaceport being developed by ISRO? I have already asked you this question. Now, options are Chennai, Coimbatore, Thoothukudi, and Madurai. So you can actually attempt this question and answer in the comment box. With that, I would like to take your leave, and I hope you have subscribed the channel. If you have not, then please subscribe it. Thank you. Have a nice day.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.